Hello friends, in the next topic of curves in the unit 5 we are going to see the components of a simple curve and their importance, right? So definition and notations of the simple curve. Hereafter we are going to use these notation in our problem solving also, right? These are the parts of the curve. See, there is some A. From A the straight is keep on moving, and from B there another straight is coming and they meet at a point, right? So this straight has to be converted to a smooth curve, right? And this point from where this is a tangent, the tangent get changed to the curve. That point is called P dot C, that is point of commencement or point of curve. It is denoted by T1. This is T1, right? And the curve where it get joined to the another approach straight, that point is denoted by PT, that is point of tangency, and it is denoted by T2. These notations and the things are common in most of the references, right? So this is point of commencement or point of curve T1, and this is point of tangency or T2, right? And the meeting point, predominantly here it is denoted as V, and mostly they will give us I, capital I, point of intersection, that is PI. And the angle subtended by these two straight in the exterior is denoted by delta. This is delta, and this is denoted by theta. The point of intersection and intersection angle, this theta or pi, and the external deflection angle is called as delta. This is deflection angle, that is intersection angle. So this deflection angle will be half the thing in the, when you join the T1 and T2 in a straight with respect to this tangent, the angle formed will be of delta by 2 in both the delta by 2, right? Delta by 2 means, so this line becomes the long chord of the curve, and this is the length of the curve. So what will be the point O, the origin from where the curve can be drawn? So this becomes the radius of the curve, right? So since it is a tangent to the curve, this angle will obviously 90 degree. Any point tangential to the curve and the line drop to the origin of the circle, it forms a 90 degree. Here also this is 90 degree, right? You can see here in detail. And you have to remember the back tangent. We have seen here it is A, here it is B. The A portion, that tangent is called back tangent, and this is the beginning of the curve or the point of the curve, right? And this is the subtangent or the forward tangent, point of intersection or point of the tangents where they get meet. I have already mentioned it's deflection angle, length of the curve. And one more term is here new, is from the curve center to the long chord center, that distance is called the mid ordinate, right? And this tangent, it is from here it is get continued and the tangent is moving towards forward direction, so it is forward tangent, right? So, and here it is the end of the curve, that is T2, the point of tangency. Right? I hope you can remember. Here it is 0 plus 0, 0 means the chain age, if the starting point may be, it may be 100 plus some chains, some links, whatever they may give. Right? So generally in surveying they denote the starting point by this is the number of chain plus links, or number of total distance plus links, the notation they adopted. Right? And the angle subtended based on the radius is again delta. The same deflection angle, it is also delta, the same angle will fall here also, the delta. So when you extend this mid-ordinate to the O, it is exact half of the curve, so this angle becomes delta by 2. And the length of the chord length is denoted by L, and this is the curve length, mid-ordinate, and the remaining portion up to the point of intersection I is called the apex distance. Right? So these are the terms you have to remember. So back tangent or the first tangent previous to the curve, forward tangent is following the curve, point of intersection or vertex V. If the tangent AT1 and BT2 are produced, they will meet in a point called point of intersection. Point of curve or commencement, beginning point T1 of a curve, alignment changes from tangent to the curve. And point of tangency, the end point of the curve is called intersection angle pi, the angle AVB or the AIB between tangent AI and tangent IB or VB is called the intersection angle. Deflection angle, the angle of point of intersection between tangent is called deflection angle. Tangent distance, it is the distance between point of a curve and the point of intersection. External distance CI, the distance from the midpoint of the curve to the point of intersection, it is also called as apex distance. Length of the curve, it is the total length of the curve from point of commencement to the point of tangency. Long chord, it is the chord joining T1 and T2. Normal chord, a chord between two successive regular stations on a curve is called normal chord. Normally the length of the normal chord is one chain, it may be 20 meter or it may be 30 meter chain is 30 meter. Subchord, the chord shorter than the normal chord, maybe lesser than 30 or lesser than 20, is called subchord. Right? Worst sign, the distance CD, the distance between midpoint of the long chord and the apex distance C is called verse sign. It is also called as mid-ordinate. Right hand curve, left hand curve. If the curve deflects to the right direction of the progress of survey, the curve deflects to the left direction of the progress of survey. Based on the direction, right hand curve, left hand curve. Now, next term is designation of the curve. That is already in the previous video we talk about the sharpness of the curve. It is the designated by two ways, by either by radius or by degree of curvature, degree of the curve, right? So by radius means the curve is known by the length of its radius, capital R. Always radius will be denoted by capital R, right? By degree of curvature we can represent by two definitions, chord definition, arc definition. If you consider the chord as the main thing and it has a standard distance of 20 meter, or you could have a 30 meter also, right? And the midline joins the origin and it is the radius of the curve, delta by 2, and this is delta. So if it is a mid means this portion is 10 meter for 20 meter chord. If it is a 30 meter, it is 15 meter, right? So the angle subtended at the center of the curve by chord of 20 or 30 meter is called the degree of curvature. If an angle subtended at the center of the curve by a chord of 20 meter is 5 degree, then the curve is called as 5 degree curve. By the arc definition, here the length of the arc will be maintained by 20 meter or 30 meter, right? So the angle subtended at the center of the curve by arc of 30 or 20 meter, the length is called degree of the curve. Usually in India, America, Canada, they use the arc definition predominantly, right? Since we need to lay the road in the arc pattern, not by the chord pattern, but we can use the concept, but predominantly we use the arc definition. So by chord definition, the angle subtended at the center of the curve by a chord of 20 meter is called degree of the curve. Already we have seen. Here R is the radius of the curve, D is the degree of the curve. Let's say PQ is 20 meter. You can have 30 meter also. That is the length of the chord. The half is 10 meter means sine D by 2 or delta by 2 is equal to what? 10 by R. If it is a 30 meter, 15 by R. Right? So therefore we require the radius of the curve R is equal to 10 by sine D delta by 2. Right? Sine delta by 2. Where D is very small compared to the big circle, 360 degree circle, your arc is a small portion, so it is small. So sine D by 2 may be taken equal to D by 2. Right? So therefore R is equal to 10 by D by 2 by, we are converting to the radians, so pi by 180. You will get 1145.92 by D. Right? If you have used the 30 meter, you will get the radius equal to 1719 or 1718.78 something. So I have rounded off 1719 by D. So in both the way you can determine the radius of the curve, right? If the degree of the curve is given, you can determine the radius. If the radius is available, you can get the degree of the curve based on the standard chain length 20 meter or 30 meter. Then by arc definition, for a circle the circumference is 2 pi r, so 360 2 pi r, which is equal to the arc of 20 meter for the deflection angle delta or D, right? We require the radius R is equal to, we are converting, you will get the same formula 1146 by D for 20 meter. If you have used the 30 meter R, then it will be 1719 or 18.9 something, right? So based on the arc. Right? I hope you understood up to this, friends. We will continue in the next video.